Hello everyone, I am Dr. N.P. Deepak, Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Today we are going to discuss a problem on Jacobian matrix. A Jacobian matrix is nothing but it is simply a matrix which depends on only a partial derivatives. In differential equations, there are two differential equations. One is ordinary differential equations, another one is partial differential equations. Ordinary differential equation means a function which depends on only a single independent variable. Partial differential equation means function depends on two or more independent variables. Here a function given as two or more independent variables. So Jacobian matrix is conformly the partial derivatives. Jacobian matrix tells how the set of output changes when we give a slightly disturbance to the set of input is said to be Jacobian matrix. Now we are going to see a problem related to a Jacobian matrix. A given function is u is equal to yz divided by x, v is equal to zx divided by y, w is equal to xy divided by z, and we have to find the Jacobian matrix of partial derivative of u comma v comma w divided by partial derivative of x y z. First we have to find dou u by dou x, next dou v by dou x, dou v by dou x, dou w by dou x, next dou u by dou y, dou v by dou v by dou y, dou w by dou y, next dou w by dou x, dou w by dou y, dou w by dou z. Three functions we have to differentiate at x and y and z. First write the Jacobian matrix formula. J represented as Jacobian, so J is equal to dou u by dou x, dou u by dou y, dou u by dou z. Dou v by dou x, dou v by dou y, dou v by dou z. Dou w by dou x, dou w by dou y, dou w by dou z. First you have to find dou u by dou x. Dou u by dou x is nothing but you have to take the u function and you have to differentiate this u function with respect to x. We can use this is in the formula of fraction. We can use u by v formula, which is nothing but v u dash minus u v dash divided by v square. U is nothing but yz, v is nothing but x. We will get dou u by dou x is equal to minus yz divided by x square. Next we taking dou v zx divided by y and differentiating with respect to x. Again we using the u by v formula, v u dash minus u v dash divided by v square and that, and we get the answer dou v by dou x is equal to z divided by y. Next dou w by dou x. Again we using the u by v formula, we will get x, y by z. First we taking the three functions and differentiating with respect to x. Next we have to taking the three functions and we have to differentiate with respect to y. First dou u by dou y. Dou v by dou y means taking the u function and differentiating with respect to y using the u by v formula, we get z divided by x. Next we taking v function with respect to y, we have to differentiate. Again using u by v formula, we get minus zx divided by y square. Next dou w by dou y. Taking the y function, w functions and differentiating with respect to y, we get x by z. Next we taking the function w. Next we have to differentiate with respect to z. So taking the function u and differentiating with respect to z, using the u by v formula, I get y by x. Next taking the function v and differentiating with respect to z, I get x by y. And differentiating the respect to z, the function w, I get minus xy divided by z square. So I taking the three functions and differentiating the three functions with respect to x, y, z using this formula. Next I am going to substitute these values in the Jacobian matrix formula. So J is equal to, first one is dou u by dou x. Dou u by dou x is nothing but minus yz divided by x square. Next dou v by dou y. Dou v by dou x, which is nothing but z by y. Next dou w by dou x, y by z. This is dou u by dou y, z by y. Dou v by dou y minus zx divided by y square. Dou v by dou w by dou y is x by z. Next dou u by dou z is y by z. Dou v by dou z is x by y. Dou w by dou z is minus x divided by y z square. Next we are taking using the determinant formula, which is nothing but keeping the first row as it is, eliminating the first column and first row, taking minus yz divided by x square keeping as it is, and eliminating the first row and first column, minus zx divided by y square into minus xy divided by z square minus, next eliminating the second column and first row we get minus x square minus z by x into minus zxy divided by z square y minus xy into yz. Next I keeping y by x as it is plus eliminating the third column and first row, I'll get third column and first row eliminated means xz divided by yz my plus zxy divided by y square z. Next, keeping as it is minus yz by x square as it is, minus into minus plus becomes z x square y divided by y square z square minus x square divided by zy minus z by x minus zxy z square y minus xy divided by yz plus y by x into xz divided by zy plus zxy divided by zxy. In this, here one z, here one z will be cancelled. Here one y, here one y will be cancelled. Here z cancel, y cancel. Here y cancel. Here also y z cancelling all the terms. I'll get finally minus yz divided by x here. These two terms become 0. Minus this is cancel means I'll get minus 2. Here all becomes cancel means I'll get plus 2. Minus into minus plus 2. Here plus 2. 2 plus 2, 4. So 0 plus 4, 4. Finally getting the Jacobian variables j is equal to 4 for these three functions. If the Jacobian matrix is equal to 0 means it is dependent. So I am getting the Jacobian values equal to 4. Thank you.